announced here in our Ballarat area August 1851. We have had 3 stages of mining since that time. The third stage of mining still exists beneath us today. First stage of mining is alluvial mining, and alluvial mining is where gold is literally sitting on the surface of the ground, easily retrieved from the creeks, also shallow diggings. These men did not have mining knowledge. It took approximately 3.5 months for that initial notification to reach all other parts of the world, and then another 3.5 months before we had a huge influx of men coming to us. A lot of these men did have mining knowledge, those being the California Corn miners, also the Cornish tin miners, who are very famous on our diggings during that time period. These men were digging for something different. They were digging for the deep leads that are beneath Ballarat and the surrounding areas. The deep leads of the ancient creek beds at 130 feet beneath the surface, they contain small pieces of gold, but also much larger gold nuggets. That is our second stage of mining, which is called deep lead alluvial mining. 90% of the world's largest nuggets came from our area during this method, including Ballarat's largest nugget, and that is the Welcome nugget that was found at Bakery Hill in 1858. That took several men quite a bit of time to bring to the surface, because that nugget weighed 68.9 kilograms in total. It's a very large and very, very heavy nugget. During that type of mining, what's wrong? It was found to contain gold, small pieces, but mostly gold powder. And that led to our third and final stage of mining, which is called quartz mining. That is carried out by very large mining companies, requiring a very large labour force, also steam power and machinery, because the quartz rock layers, or reefs as they are referred to, are found 300 feet beneath the surface. Those reefs are as deep as the roof of the floor, as wide as this building, and they ran for miles or kilometres in either direction from any point. There was often more than one layer of quartz, so mining companies are going down to a depth of 1 kilometre beneath the surface. The reefs are then blasted with an explosive called black powder, and the smaller pieces, as you see here, are then brought to the surface. Once at the surface, they are taken to a battery house where massive steam-driven hammers crush that rock into a fine powder like that. That fine powder is then washed across tables to extract the gold from the quartz powder. During that time, those tables contained mercury. Mercury and gold has a natural attraction to one another. So the mercury would extract all of the gold out of that quartz powder, and the rest of the quartz powder is then washed away. The mercury and the gold is then mixed together to form a thick paste called amalgam. And it is the amalgam that is brought to the industrial blacksmith like myself to purify the gold. But before I can purify the gold, I need to remove the mercury. And to do that, I would use a retort. Cast iron pot, place the amalgam inside the retort, and seal the lid shut. Retort is then placed into a fire or a furnace to boil off the mercury. Mercury boils at 360 degrees Celsius, and the vapours simply escape through the end of the tube, don't they? How comfortable are you feeling now, folks? Not very, are you? Because most of you know mercury vapours are extremely poisonous. And the first stage of mercury poisoning is madness. And the second stage of mercury poisoning is death, most likely within 2 weeks of the initial poisoning. So to overcome that problem, the end of the tube is simply the bucket of cold water. When the mercury vapours come in contact with the cold water, it returns back into its liquid form, and it then falls to the bottom of the bucket. The mercury is then returned to the battery house for reuse. This not only saves the mining company a lot of money, because the mercury is not available in Australia, it does have to be imported, and it's very expensive to do so. But it also extends the lives of any men using the mercury having that knowledge. Gold is still not pure at that stage. Gold naturally contains copper, silver and iron within it when it does come out of the ground. It is then placed into a crucible like this one. It is made of plain graphite and can withstand temperatures at 2000 degrees Celsius. In with the gold, the cleaning agent called flux is placed, and that is either potash or borax. The crucible is then placed into a furnace to melt the gold. Gold melts at 1064 degrees Celsius. When we melt the gold, we're also melting the impurities within the gold. And the gold being heavier, it simply goes to the bottom of the crucible, and the impurities being much lighter, they make their way to the top and they attach themselves to that flux, causing a crust floating on top of the gold. So when the time comes before the gold, that crust floating on top of the gold will go to the back of the crucible, it will stick to the crucible, and I'll then be pouring 99.99% pure gold or 24 karat gold. And that is the sole purpose of the industrial blacksmith, is to purify the gold for the mining company so they can get the best price for it at sale. My goal is currently melting my furnace at the moment, folks. It is at this stage that I'll ask you all to remain behind that line I have down there, because I have been told to tell you that you are at a safe distance if I have an accident. My goal will be at 1200 degrees. It will be a liquid molten metal, and if I do have an accident, I will be splashing it away from myself. So I can now allow everybody to know who is in the second and the third row that they are entirely safe if I have an accident, because by the time that 1200 degrees of liquid gold passes through the person in the front row, it will be solid when it comes out the back of that person, and it will then only bounce off those people in the second and the third row. So, racing and get in the front seat, folks. Now, if you do wish to take a photograph of that happening, please have your cameras ready, because I'll only have the 16-second window before the goal in front of you. So this mould that I will be placing down onto the table now has been preheated, as you have seen, so it can withstand 1200 degrees of liquid gold being poured into it. If the mould was not preheated, it would just shatter on the table. The gold goes off like fireworks. It's a chemical reaction. It doesn't very pretty. It's very dangerous and also very expensive. I will be looking for a slight colour change in the gold so that I know it's at optimum temperature. If I take it out too early, it is not liquid enough to pour. If I'm 10 seconds too late, I will have burnt the gold. You make sure that child does not go any further than that white line for students.
It's real gold. It's real. Move by this side. Clear view. Yeah, that's the best friend.
It's coming. It's coming. Lava.
Gold is an amazing conductor of heat. If given a reason, it can lose that heat very quickly. 1200 degrees, as I said, that allows me enough time to carry it over to the table and pour it into the mould in front of you. A lot of that heat is now transferring out through the bottom of the mould into the top of the table. So in a very short period of time, that gold is 100% solid. Totally solid. I do like to ask, who wants to race over here, grab a piece of gold and take off that door with it? I'm going to show you why you can't do that, because at 900 degrees it is a piece of timber on contact. It's not going to happen. That gold is now going to take 2.5 hours to cool naturally just sitting there. I know I love gold that much. I've got 2.5 hours to stand here and watch that happen. What you don't 2.5 hours to sit there and watch that happen? Really? Did you just miss the part where I poured the liquid? I don't even know why I bother half the time. I guess I can speed up that cooling process so I can get you out of home room. said, gold is an amazing conductor of heat. If given a reason, it can lose that heat super fast. 900 degrees going into that trough of water. Please raise your hand if you think that water is now hot. Please raise your hand if you think the water is not hot. The water's not hot, folks. What you saw happen to the heat from that gold is it escaped the steam straight up into the air. Gold has to contact something to conduct or release its heat. It was in contact with that water that was immediately against it, boiled off and went up the steam, as you saw. At 900 degrees on the table, I can put my finger within 1 millimetre of that gold and not feel any radiant heat whatsoever. I can from the crucible and the mould, but not the gold. So I guess all I got left to do now is to think about picking that up. Has it been 40 seconds yet, has it? No. What do you care? You've paid money for entertainment from coming in, haven't you? Very, very handsome. Very, very, very intelligent industrial blacksmith. Burn his fingers for entertainment, don't you?
Yes.
Wow. Who knows? Multitude of guesses. What a horrible bunch you are. I guess it's not your hand then, is it? Ah! There you go, folks. 100 troy ounces of pure 99.99% gold, or 24 carat gold that has now been smelt or purified. 100 troy ounces is 3 kilograms.
Can I have it?
Doesn't. 3 kilograms, folks, to give you some sort of idea, concept, weight and size difference between items. That is the same weight as a 3 litre bottle of milk. Vast size difference between the two. As you can see, that's how dense gold is. Is the front shiny, folks? Yeah. It's normally a little bit better, but I started using a new mould today. Now, you're all sitting there wondering, how much is that worth? I know you are.
Yes.
Would you like to know how boring that question gets? I mean, I can tell you it is right up there. Maybe some of the more intelligent people in the room would like to know how quickly I could have picked the gold up from that top. I do find that more fascinating than the price. Would they like to know the answer to that? So it's 3 of us, you know what, not surprising for a bunch of people that just want to see somebody burn the engine with big gold. But it was as soon as the steam stopped, folks, 7 seconds, 900 degrees gone in 7 seconds, boom. I find that more fascinating than the price. But then again, other than us 3, the rest of you are just sitting there going, how much, how much, how much, how much. And you're way out with that price. Way out. So, an exciting thing, but not an exciting thing. That's the highest I've seen this bit of gold at, 300,000 Australian dollars. Now, it has jumped up a bit in a very short period of time. The reason for that is there's obviously something bad going on in the world, and that's what raises the price of gold. But it is exciting to absolutely hold this at the moment. Now, the reason why gold is worth so much, folks, and this is my opinion, told I try to build those, but anyway, it's my opinion. It's not because it looks pretty around your necks, on your fingers, and wherever else people put this stuff nowadays. It is because gold can conduct heat like no other metal can. Gold does not rust, gold does not corrode. You essentially cannot kill gold. The only damage I can do to this gold, as I said before, 10 seconds too long in that furnace, and I burn the gold. It turns a horrible orange brown. It does aerate. If I do make that mistake, all I need to do is melt it down and pour it 3 or 4 more times, and that then restores its natural density and colour. And as most of you know, it's in phones, cameras, computers, iPads, all of that electronic equipment has gold in it because it does conduct that heat well. Takes the heat out of those very, very hot zones and puts it into a safe place within that item. If they did not have gold in them, or that gold was not connected correctly, they would just simply burn on startup. That's how hot your electronics get. As I said, my opinion on why I believe gold is worth so much. That does conclude the demonstration for this afternoon. I do hope you enjoyed that, and we can leave the these doors open for you.